Hello everyone. All right. Morning class. Morning Justin. Thank you for being here on our second meeting. If you read my email from this morning, we are going to cover our unit number 1. And also, if you have questions, because I have received a lot of email during the weekend, I will be working with those emails today after this meeting. But if you have questions, you can stay after class, and we can go over your questions. Audio, video, is it good? All right. I post our first meeting video, I think Thursday. I forgot to mute the microphone from the recording software, so if you see it, you notice that the first 12 minutes I was doing a voiceover, so the voice and my face expression or my lips are not syncing with my voice. All right. So yeah, let's jump over to our class. First thing that I want to show you before going through our class today, this is Blackboard, as you know. A few things that I just want to point out. The first thing on the announcement when you enter to the class Blackboard, on the top on the announcement, this is our link, and you know it because you are here. The other thing that I want to go over is our classroom. All the documents or the documents that you need from now on during the semester to submit your work are in the Our Classroom tab. Right? The first folder, assignments and written work, on the third item or the third folder is the one that contains the worksheet of the day. You enter there and you should see this. All the worksheets of the day are available to download today. The other thing that I want to go over, again, Our Classroom, assignment and written work. Below the third folder, so number 4, worksheet of the day, keys. There, after the due day passes, the keys for the worksheets are going to be available. So when I grade your work, you can go and compare your work versus the keys. So that way you will have a better understanding of the feedback that I'm going to provide you on your work. Okay, this is key for the worksheet of the day. I believe this one is 910. Yeah, 910. This is the review topics or prerequisites skill review for unit 1 to 3. On the YouTube tab is where you are going to find all the class recordings. Submit here is a tab that contains 3 shortcuts for the participation log that you are going to submit the participant log for week number 2 today. So you're going to enter here and you're going to submit that there. You haven't downloaded the document, it is here. This is the document. This is the participation log. Again, on submit here, you are going to find the folder for the worksheet of the day, to submit the worksheet of the day, to download and submit the worksheet of the day. And the third one is where you are going to submit the written work, but we haven't done anything that required written work yet, right? But keep in mind, for quizzes, tests, knowledge checks, and the final exam, you are going to submit written work, right? And once you enter on this folder, you are going to see individual folder for each type of the assessment. Right. Another thing is my grade tabs. Please check your grades on a daily basis and check if I have commented on your submission. All right, that way you are going to gain more insight of your submission. If there is any feedback or any comments, you are going to know more about how I grade your submission. Any question? All right. So before going through unit number 1 examples, what you are seeing here is the worksheet of the day 9-10, the one that covers the prerequisite skill review. And I want to stop here just for a moment. I need you to know how to read intervals, and this table is important. You will see, if I can draw a straight line, well, we have here, this table here contains 3 columns. They are equivalent, but they are different type of notations. A set, it is a collections of elements. The collection that we are going to be working on the class are going to be numbers. Those numbers, we can put them together in a set. We have 2 types of sets. We have infinite sets and definite sets. The majority of the cases, we are going to be working with infinite sets. And there is when you are going to see interval notation. In the interval notation, we use A and B are 2 numbers that are representing the collection. All right? A and B are the boundaries of that set. For example, if I'm going to say that A is equal 1 and B is equal 5, all right? Remember that variables are placeholders, are placeholders for any value in our algebra class. And then I write this. This is a set with boundary from left boundary is 1 and right boundary is 5. But there is 2 types of using those boundaries. Not included and included. The first one, where we are using parentheses, boundaries are not included. And when we are using square brackets, to put this a little bit bold, when we are using square brackets, boundaries are included. Why it is this? Why we need to do an extension? Well, you need to remember that right now this is an interval and we are working with an infinite set of numbers. That means that between 1 and 5 we have an infinite amount of number. Infinite amount. And what is that? Why is that there is an infinite amount from 1 to 5? Does that make sense? What do you think? Does that make sense? Anyone who would like to write in the chat why what I'm saying is true? Why is this true? What do you think? How could you explain someone that from 1 to 5 there is an infinite amount of numbers? Because if I have $5 on my wallet, do I have an infinite amount of money? What's happening here? So if you have in your bank account $5, does that mean that you have an infinite amount of money? Okay, Rachel, thank you. We are not just talking about 1, 2, 3, and 4, and 5, right? We have decimal in between. And that makes this set from 1 to 5 an infinite amount set. Because if we're talking about the real numbers, we need to include the decimals. If we are including just whole numbers, like when we are working with money, well, we have decimals, but let's just think that we are working just with whole numbers, with just dollar bills. 1 to 5, I have only $5 in my bank account. Okay, because if we are talking about just by whole numbers, 1, 2, 3, 4, 5, that's a finite amount. That's a finite set or a finite amount of numbers. All right. Okay, so this is going to be important. If you have questions about how to read intervals, just let me know. Okay, you are going to be using this a lot in our class. Another thing, we are not going to use a lot of the set notation, but in case we are dealing with a finite amount of or a finite set, you want to use a set notation whenever we are working with a finite amount or a finite set or a fixed amount of numbers. If we go back to our sample from 1 to 5, but now we just take the whole numbers. This is how you write a finite set. Okay, this is we have here exactly 5 elements. There's not an infinite amount of elements, and you see that now we need to write every element on the set, and we use curly brackets to determine or to specify or to say that this is a set notation. We are using a set notation. The other way to write a set is by using a graph notation. If you use a number line, you are going to be using open circles or solid dots. Open circle means I'm not including that boundary here. The boundary A is not included. It's the same as using open parentheses. Okay, solid dot is the same as using a square bracket. Okay, if we use inequality symbols, you are going to see that less than does not include A, but less than or equal does include A. Okay. So that is the first worksheet of the day. Now, okay, so this is worksheet of the day that it is due today. This is for unit number 1. On the worksheet of the day, make sure that you are writing all your answers. If that exercise requires multiple steps to solve it, you need to put those on the worksheet of the day. If you don't, then you are going to lose points. Okay, I'm going to show you something about symmetry with respect to the x-axis. There is a few ways to determine symmetry with respect of the x-axis, y-axis, or the origin. Okay. One of the ways that we are going to do that test is by just looking at the graph. Okay, if we can identify any graph visually, any symmetry of the graph visually, we are going to be able to determine if there is any kind of symmetry. To do that, let me grab one presentation here. All right. So what you're seeing right now is the same graph that you have on that worksheet today. And here we are going to determine what type of symmetry do we have. And that's a question for you. What is the type of symmetry that you are seeing here? This graph, does this graph have any kind of symmetry? Let me know down in the chat. Rachel, you said origin. Amanda, you said yes. What type of symmetry? Origin, x-axis, or Celine, you said x-axis. Amanda, you said origin. Chem has symmetry across the origin, just in origin. All right. So it is symmetry with respect to the origin. How can we determine that? Just visually. Okay. So I'm using this PowerPoint animation just to help you or to give you a representation of what I do in my mind anytime I need to test symmetry just visually. So I'm going to grab with my mind one fragment, one half of the graph. Right now, I just selecting the lower left part of this graph. Now, to determine origin with respect to determine symmetry with respect to the origin, basically what we need to do is to flip it vertically and horizontally, right? So in my mind, I'm going to grab that part of the graph. I'm going to flip it. Right now, I'm flipping it vertically with respect to the x-axis, and then one more, reflecting it with respect to the y-axis. And if both parts match each other, then there is a origin with respect to there is a symmetry with respect to the origin. All right, and we can do that either way, from the right half part of the graph. You reflect it with respect to the x-axis, to respect to the y-axis, and you got the same thing on both sides. So symmetry with respect to the origin. Okay. So what you are seeing here is basically how I imagine or how I test symmetry with respect to the origin in my mind. And this is something that you want to do because on the test you don't want to waste time. If you need to test symmetry just visually, you need to be able to be creative and use your mind in order to determine that. All right, the next one, what kind of symmetry are we seeing here? Which of the three? Y-axis. I'm taking the left fragment of the graph and reflecting it across the y-axis, and I notice that it matches perfectly, or it lands perfectly on the right part or the right fragment of the graph. Left and right are the same. The only thing is you reflect it across the y-axis, you are going to see that they've matched perfectly. Last one. What kind of symmetry? X-axis. Basically the same as we thought, the same method. The only thing that now top and bottom, or bottom and top. That is the meaning of having an x-axis symmetry. All right, so that is visually. Quick question, which of these three is not a function? Let's say that this one is A, this one is B, and this one is C. Okay. All right. How can we determine that C is the one that is not a function? Is there a test? Selam, that's correct. We can do a line test. And I can grab something here. I can use almost vertically line. Okay, so the vertical line test is if we grab a line, vertical line, and we move it across the entire graph. If we are seeing that that line only touches once at a time the graph, then it is a function, right? So it passes for the first graph. The second one, you see that it touches just once. And the third one, there, here is when we are seeing the problem. Is where we are seeing that this vertical line test is touching twice the graph. And this is not a function. It is not a function because for one x value, we are getting two y values. All right, and this is ambiguous. And the purpose of a function is to grab information from it. So whenever we have one input, we should have one output. If we have two output, then there is not a function. There is ambiguity within that functions, and hence its purpose fails. So there is no function. All right. How to test symmetry algebraically? That's what we are going to do with the Alex exercise. And then lastly, we are going to go over this exercise. So if you have questions about this, we are going to work together with this one. All right. Okay. Exercise number 1. So we need to determine the symmetry of these relationships. All right. We are not talking about functions yet. We are talking about relationships. A relation between two variables. These variables are x and y. All right. Then we are going to start working with functions. But right now, what we know about this equation is that they are a relationship between x and y. Okay. So let's determine symmetry algebraically. We have 3 tests. We have the x-axis, the y-axis, and the origin test. You need to do the 3 tests. On the test or quiz, if you are going to check symmetries of a relationship algebraically, you need to do the 3 tests. Your conclusion should be it fails or it passed 3 times. If you just identify, let's suppose that this one has an x-axis symmetry. This is just supposing. let's suppose that this one that we are going to do has only an x-axis symmetry. And then you do the test axis symmetry and you find that it indeed passes the x-axis symmetry. If you leave it there and you do not go over the x-axis, y-axis symmetry test or origin test, you are missing points. The way that you solve this exercise completely is to going through the 3 tests. All right, so I'm going to do this one. The relationship that we're going to be testing, I'm going to write it here. So we need it for reference because we are going to compare our results with the original equation. All right, so on the top we have the original equation, and we are going to start with test x-axis symmetry. Okay, so x-axis symmetry means how do we do an x-axis symmetry? Can someone tell me on the chat what do I need to do in order to test if this equation or relation has an x-axis symmetry? Amanda, you said make y negative. Okay, that's correct, Amanda. I would like though to use substitute y with negative y. All right, substitute y with the opposite value of y. Okay, yes, we are going to read this as negative y, but what I want you to know is that this symbol here is being used to use the opposite value of y. If y is negative, then its opposite value is positive, and vice versa. All right. The negative here is being used to express opposite value, and that's what we are going to do. See that I'm going just to replace y, which is here, with its opposite value, and the rest is going to be the same. Okay, so this is the first step of that test. Next, I'm going to solve the equation. One thing in mind, one thing that I like to consider is the structure of the original equation. Okay, we are going to compare our result with the original equation. This is our reference equation. Okay, so you want to be consistent on the structure. When I say that, is that you know that you can manipulate or rewrite this equation. You can move everything to the left side, or you can add. This is an equation. You can cancel something on one side and put it on the other side. You can do whatever you want as long as you are following the algebraically rules that reign on this equation. Okay, but I want to follow the structure because I want to do a direct comparison. All right, I want to know what happened with that. How can I solve this? What I should do? What I need to do? How is this equation is going to be transformed? Or what should be the next step, or what will you do? You will simplify the equation. Yes, Amanda, you will simplify the equation. That's correct. How can this equation be simplified? Justin, that's correct. We have an exponent that is an even exponent. When we multiply two negatives, negative, they cancel each other. Having an exponent that is even is basically getting the base. The base in this case is negative y. We have two copies of negative y and we multiply them together. Hence, we have two negatives that we multiply them together. So that negative gets cancelled. Okay, so we have y squared and the rest stay the same. Plus x minus x equals 0. And by this point, since this is the same structure as the reference one, we don't need to do anything else. What we need to do is just to copy, well, what I'm going to do is just to copy and paste. But what you are going to do is to compare the original equation versus our conclusion from the test. Okay? Are they the same? Okay, yes, they are the same. So how do we finish this? Well, you can put x axis has x-axis test, I should say. Or you can put, let me put it more simple for you. As x-axis symmetry. Symmetry, is that correct? How you write it? Yeah. All right. So that's the first test. But we are going to do the same because we are not done yet. We have two more tests to do. So we're going to test the y-axis symmetry. And I'm going to copy this. Excuse me. Put it there. Again, I have my reference equation on the top because I'm going to use it to compare it against my result. Test y-axis symmetry. All right, and to do this test, what we are going to do? What will be the first step here? Just to make x negative or subs x with its opposite value. Okay, so y squared stay the same, then we go to x, we have x, and we are going to replace it with its opposite value, and everything else stay the same. Minus 6 equals 0. So at this point, we can stop here because the structure of our result here, we can simplify, yes, but it won't be necessary because we can compare this one directly with the reference equation. Okay, so I'm gonna stop there. I'm not going to make unnecessary steps in this situation, so let's go and just compare them. Are they the same? No. Okay. No, they are not the same. So this is your solution. This is how you solve this part. Fail. No y-axis symmetry. If you don't put this is your solution. If you omit this, which is the solution, fail or pass, you are missing points. You are not completing the exercise. All right. So one more time, we need to do the test now for the origin, with respect to the origin. All right. If someone can tell me what to do to start this test. Okay, Joseph, yeah, sub value for x and y, and that's correct. Remember the animation that I present to you when we determine origin with respect to the symmetry with respect to the origin. We do two reflections with respect to the x-axis and respect to the y-axis. Well, algebraically, it means that we are going to sub y with its opposite value and x as well with its opposite value. So first step here will be getting those substitution done on our equation. Okay, and by this point, what we are going to do is to simplify. And the only thing that I'm going to simplify here is going to be the first term, the second term that contains negative x. I'm gonna leave it there as it is because I just want to do a comparison between this result and the equation, reference equation. No. Okay, what is the solution here? What is the conclusion here? Fail. No origin symmetry. Right? And this is how you complete the exercise. If you omit one test, you are going to lose point on the exercise. Okay? You need to do everything. On Alex, what you are going to do is to check on x-axis. Okay? On Alex, you are going to remember when taking the test or the quiz. On Alex, the only thing that you're going to do is to check on x-axis, right? But on Blackboard, you are going to be submitting the written work. The written work, this is an example of the written work. If you have a test or you have an exercise where you are testing algebraically for symmetry, you need to present all these steps. All right? If you fail to present these tests, your points that you gain from Alex are going to be deducted. Okay? You are not going to receive points for this exercise. Any question? Is that clear? Right. Exercise number 2. Okay. So we know a relation between two variables. We can express a relation between two variables in many ways. Typically, we represent relation x and y in an equation. y being the dependent variable and x the independent variable, right? So the value of y depends on x, on the x value. And we create an equation. Also, we can translate an equation or a relation into a graph using the Cartesian plane, right? So that is another relation. Then we have some kind of special relationship, and we are going to call that special relationship function, right? A function is a relation, but it contains more specifications. And one of the specifications for being a function is that if we have one input, we should get an unique output, all right? That is why we have the vertical line test. The vertical line test is telling us for this input you have a unique output. Okay, for one x value, you will have a unique y value. Okay, so since a function is a relationship between x and y, or between two variables, input and output, and they also can be presented as graph, symmetry now have also a relation, or it is related to a function in a way that we are going to determine if a function is even, or if a function is odd, or is neither. Okay? And the way we use symmetry, or the relation between symmetry and a function that is even or odd, is if a function is even, that function or we can see that the graph has an x-axis symmetry. Okay? If a function is odd, then there is an origin symmetry. Okay? It doesn't look well. Well, you got the point there. Okay, even, a function that is even, we are going to see an y-axis symmetry, and a function that is odd, we are going to see a origin symmetry. Neither, there's no symmetry whatsoever. And what happened with the x-axis symmetry? Why am I not talking about x-axis symmetry here? Can anyone tell me why there is not relation, or why the x-axis symmetry here is not related to even or odd? If I tell you I have a function that has an x-axis symmetry, is that correct? Is it correct to say this function has an x-axis symmetry? Okay, Kent and Justin, no, that is the correct answer. Why is that? Why it is going to be impossible to have a function with an x-axis symmetry? Here we are seeing a graph with an x-axis symmetry. Rachel just saying can have two same x point. I think you got the right idea. The way you will want to rewrite that is that we cannot have two outputs for the same x points. Here, what we are seeing, if we do the vertical line test, we need to remember that for one x value, we are going to get from this graph two y values, and that that fail to be a function. Okay, for a function we need to have a unique output for an x value. Okay, so any graph that has an x-axis symmetry, it is not going to be a function. And you said you are correct. If you do the line test, it will hit two y values at the same time. Okay, that is why a function is never going to be or is never going to have an x-axis symmetry. All right. So the function r, it is represented by this graph. Is this function even, odd, or neither? What type of function do we have here? It is even, and we are going to determine that graphically, because that is the only thing that we have here. We don't have its function rule, its equation, right? So we are going to use our mind the way you like to use it. The way I like to use it is being creative and grabbing with my mind one half of the graph. Usually I start with the left part, the left half of the graph, and then I want to imagine that part rotating with respect to the y-axis. Then I try to match it with the right half of the graph. If it matches perfectly, we have an even function. It is not odd because clearly it doesn't have symmetry with respect to the origin. But is it possible that in general, if a function is even, could that function be also odd? Halima, no, the answer is not in general. If a function is even, that function is not going to be odd. Okay, Rachel, you're asking if this was on the test. Rachel, no, that's a good question. For this type of exercise, where you are going just to look at the graph and to determine if there is a function is even or odd, you don't need to do written work. On the written work guide that it is on Blackboard, I have put some example of exercise that will require written work. Usually, if I do written work to present an exercise, that exercise will require written work on the test. Okay, that's a good question. Okay, so for this type of exercise, no, you don't need to do written work. On those exercises, I can talk in detail later about that, but on those exercises, basically what you are going to do is to write down the number of the exercise and you are going to say solve graphically. Okay, and that way I know that you solved that one with your mind because it is not required the written work for that one. Okay, the other type or the other way we can determine if a function is even or not, now we are going to work with this one. And for this one, we don't have its graph. Yes, we can take our graphing calculator and we can put the graph, or we can draw the graph of this function there. Okay, but since the exercise is giving you the equation rule, you need to show written work. So that is what we are going to do. Basically, is the same format or the same method as we did for the last exercise, where we test for symmetry. Now we are going to test for even or odd. Okay, and again, you need to do all the tests. There is one exception though here. I have told you that in general, if a function is even, it's not going to be odd unless it is a constant function equal to 0. Even though you should have one or another one, if at least you need to tell me that one of the tests is going to fail. An example, if you find that a function is even, then for the test for odd test, what you are going to say or what you are going to write down is, since this function is even, it is, so you can get to that conclusion that it is not odd. Okay, you need to tell me in some kind of way that you are doing both tests. If you do just one test and you see that test pass, it is even, then for the next test you should say, look at test even test, it passed, hence the test for odd failed. Okay, you need always to tell me some kind of way how you are solving the exercise or how you are doing the tests. Does that make sense? All right, so here there is a big question to do, to answer. What is that question? How can we do an even test? How can we test a function for even? I'm going to put here in blue, just as a reminder that even is related to the y-axis symmetry. So x for negative x, or opposite value of x, or plug in negative x. That's correct. That is how we do the test here. And Salem and Rachel, both of you are correct. What you said is the following. I'm going to rephrase what you put on the chat. We are going to check this. If we plug in negative into x in this function, if we plug in negative x, does the equation stay the same? At the end, are we going to have the same equation? If this is yes, then the function is even. If no, then the function is not even. Okay, and again on blue, I'm going to write what we do if we are just testing for symmetry. It's going to be subs x with opposite value of x. Okay, what is in blue, it is optional. If you are doing written work, what it is in blue, you don't need to write it. Okay, I just put in that there just as a reminder. Okay, so let's start. Just going to write the negative x here, and now with this color, I'm going to write everything else. To put this here. I should use parentheses in function as well. Okay, that's first step. And now what we want, since this is the reference equation rule that, or function rule that we are using, right? This is the equation that we are going to compare to, right? I want my solution or my final equation something that resembles this structure, so I can compare it directly. Okay, I want to make it. If I need to simplify, I'm going to simplify just to have a direct comparison with the reference or the original equation. So that means that I need to simplify. And help me on this simplification. Can you tell me what is going to be the first term and the second term? What is going to be this term, the first one? Amanda, you said positive 4x to the fifth, correct? So my x. Okay, so what is happening here? The power is odd, so we have 5 copies of negative. So 2 of those pairs are going to cancel each other. When we multiply 2 negatives together, they cancel each other. So we have 5. So the first 2 cancel each other, 3 and 4 cancel each other, and then the 5th negative stay. But in front of 4, we have a negative as well. So the negative that it is the remainder negative from the exponent, or from the power part of this term that is there, it is cancelled with the negative of 4. All right, and I see here that we are going to have negative 5x. The same thing happened. 3 is odd, so as a remainder from the power part of the term, we have 1 negative. All right, I think so. This is sufficient and enough to do a direct comparison. So we are going to compare this one with this one. Okay, and it's clearly that they are not the same. So one way that I would do this, not equal here, h of x. Okay, this is how I like to present my written work for this exercise. Okay, and the last step is going to be not equal or equal. And since this question, you answer this question as we don't know, so this is how you end the test. Fail, not even. Something like that. Something that tells me that the conclusion of the test. All right. My recommendation is always do the even test first, because then the test for odd depends on the even test. Because let me go to do. Let me put it next to this. Okay, we need to remember that this is origin, symmetry. So yeah, what is the question for this test? What will what we need, what are we going to compare to answer our question, to answer if the function is odd or not. We know that what we are going to be doing is substituting SUVS. We're going to substituting y with negative y and x with negative x, but that is for symmetry test. But now we are doing the odd test. Salam, you missed one negative. Okay, the question here will be if h of negative x is equal to the opposite value of h of x. Okay, and here you can see why I have recommended to you to do the even test first, because from the even test we are going to get h of negative x. H of negative x, it is here. Okay, so here is h of negative x, and we are going to use this result in our odd test. Okay, so we know that it is there. I'm not going to use it yet. I'm going to focus on negative h of x. So this is not going to be difficult here, because a negative in front of an equation, what we are going to do is to change or flip all the signs of the terms. And here we have two terms. All right, so we distribute this negative within all the terms. And what is the result? I think I'm missing a 3 here, a 3 here. Can you tell me positive or negative of positive for the terms? All right. So these two cancel each other, and this one and this one, that is negative. All right. And now we can go and look at this result here. Are they the same? Yes. Equal to h of negative x. Okay. So the answer of this question is yes. We finish with pass. Function is odd. All right. On future topics later on the class, we are going to see that a relationship, or we are going to explore more a function that is odd or even, and you are going to see that that is going to be related to the degree of the polynomial or the equation rule, but we are going to talk about that later. I don't want to complicate things yet. All right, so what are you going to do on the test, on Alex? Check mark on odd, click submit, but on Blackboard you need to submit your written work. And here is the written work. All right. Another thing that you want to do, just a moment, checking here. Is the video still good? All right. Are you okay? Just a moment, I just making sure that everything is good with the recording. Are you still running? Yeah, I think so. Okay, I hope my video is good. All right, what I was doing? Okay, last exercise. You need to be able to read a graph. Okay, reading a graph. That's what we are going to do here, and that is very relatable with this last exercise on the workshop today. You need to be able to read a graph. So let's do this one together, and then I'm going to show you something that will help you. Okay, so right on the chat, I think you don't see well. Let's start with, can you read there? All right. What is the answer? Okay, it is yes. Okay, first thing, the question is f of 3 negative or positive? Well, the actual question is if f of 3 negative, and then the answer should be yes or no. F of 3, first we have here a function. The function f is represented by its graph. There is the graph. 3 is the input of the function. 3 is here, right? And then we need to find the value of the function. The value of the function, it is represented by the point on the graph. 3 is here. This is the input. The output of the graph, it is here because that is the point that is related to an input of 3. Okay, I can go and put here the coordinates of that point. It is positive 3, negative 4. How we answer this? Well, if f of 3 negative, yes, you got it correct. The value for the function when x is equal to 3 is negative 4. So yes, it is negative. Okay. Okay. Let me see how can I do this better. I think if I just print screen, come on, and put it here. Yes. I don't know how well this will look on your screen. Can you read the question there? Okay. All right. For which values of x, f of x is equal to 0? Okay. Write on the chat what it is the answer for this question. Okay, I have 0, I have negative 3, comma 0, negative positive 2, I have 0, comma 0. Okay. The first thing that I want to discuss, what is the meaning of f of x equals 0? This means that the y value is equal 0, right? This means that we are talking about x-intercepts. Okay? Something that we are going to explore during the whole semester. X-intercepts and the meaning of them. Right now, what we know is just f of x equal to 0. It is the same as what are the x-intercepts. And we are looking for those values. We are looking for the x values. So the way we are going to write that, well, the first thing is that how are we going to identify them? We are going to look at the graph. Anytime the graph touches the x-axis, those are x-intercepts. All right. Now, so we have three x-intercepts. How are you going to answer this mathematically speaking properly? So we have a set of three numbers. If you write -3, 0, this is incorrect. Why is that incorrect? Because this is a point. And the question is asking for the x values only. This is the coordinate of a point. Yes, the point is correct. -3, 0 is where we have one x-intercept. But this is incorrect for this exercise. How you want to answer this? We have -3, x value of -3, x value of 0, and x value of 2. This is completely correct for me. But if we want to be very strict on how we write sets, you should use curly brackets. So the x values of that makes f equal to 0, the function f equal to 0 are -3, 0, and 2. Another way that you can write this is x equal -3, x equals 0, x equal 2. Okay? But for me, if you write this only, that's okay for me. And I believe this is what you need to write on Alex. Right? I don't think, let me see. If there is more than one value, separate them by comma. So what you want to write on Alex is this. Okay? Okay. How should I do this? I think if I copy, paste this, yes. And then if I copy this here, can you read this well? For which values of x if f of x less than 0? How would you write, or how would you answer this? For which value of x? How would you answer this? What is the meaning of this? What is the meaning of f of x? Amanda, you said -3, -4. Rachel, I like your answer, but I would like you to be more specific. Camed, -3 and 0. Okay. So first thing is that we are going to be looking for negative values. Okay, the negative value of the function. The negative value of the function are determined by the negative y values. So below the x-axis, or everything below the x-axis is negative. So all this here, it is negative. See, all this here is also negative. All right. First question, how many points or how many x values are there? How many x values do we have? I highlighted two fragments of the graph. How many x values are within those two fragments? Justin, Joseph 4. Are you referring, okay, Justin, Joseph 5. Would you elaborate more, Justin and Joseph, on your, Amanda, also you do, on your answer? 4, 5, 3. Joseph, just think 2, okay? 3, okay? I like your answers because I think you all have the right idea. Because as Justin just wrote, -3, 0, 2, and 2 and 5, you are focusing on the boundaries. These points here are, the x value are here, -3, this one is 0, this one is 2, and this one is 5, all right? And those numbers are the boundaries, or are the numbers that separate the positive part of the function from the negative part of the function. Okay, and that's one thing, and we are going to use those numbers. But now the question is, how many x values are within those fragments? These fragments are highlighted. How many x values are here? Make sure there is an infinite amount of x values. Whenever we have a fragment, the way a graph is built is with an infinite amount of points that are very close to each other, right? So we have an infinite amount of x values. Infinite amount. And whenever you have an infinite amount of x value, you are not going to write to the rest of the time in a test all the x values that are there. So what you are going to do, so infinite amount, so this is a set, remember this is a set, so you are going to use an interval notation. Okay, and why did I say that I like the idea of putting -3, 0, 2, and 5 is because those are going to be the boundaries of our intervals. Okay, so I'm going to zoom onto the graph. I'm going to erase a few things here. I'm going to erase this. I'm going to use another color, so make it more explicit. Okay, in brown, red, I think velvet is that color, I don't know. I'm going to highlight those numbers. I'm going to highlight the fragment of the graph. Now help me to construct the intervals. The interval that represents this part is highlighted. We know that it's from 3 to 0, right? But we are looking for the x value that makes the function equal less than 0. less than 0. That is important, less than 0. Do I use here parentheses or square brackets? Richard, we are going to use, thank you, Rachel. We are going to use parentheses. Why is that? We are looking strictly for less than 0. If you include -3 on your solution, that is incorrect, because at -3, the function is exactly equal to 0. We are looking for less than 0. So we use -3 and 0 as boundaries. Okay? So Rachel, you were right on -3, 0 using parentheses. Now, let's talk about this one. And I'm going to help you because yes, -2 is the left boundary and we are going to use a parenthesis there. But what with 5? Do we use a square bracket or do we use parentheses? We are going to use a square bracket. And why is that? Because at 5, f of 5 is still a negative value. Okay, 5 is also a boundary here, but 5 is not an x-intercept. So we use a square bracket because we need to include 5 as part of the solution. Okay, so you go here, down here, and you are going to use, this is the tool set for this exercise. So you are going to use this one to write the first interval from -3 to 0. Or you just can type the parentheses. Then you are going to use this one for union. Okay, so this is going to be 2, comma, square bracket, 5 square bracket. Okay. Any question with this one? All right. So if you have a worksheet of the day, they're available. I want to review something with you all together because here are when we are going to read this graph and to answer the questions that are on the worksheet of the day. There are some points here that, or some questions that might confuse you. Okay. So take a moment, go to the worksheet of the day, and let's go to the last exercise. And I'm going to be discussing what I'm going to be discussing is going to help you to determine. Let me see. Well, you want to answer correctly the domain and the range. If you have questions about that, let me know. I'm going to go over to talk about the behavior of the graph. And that is going to help you to answer question H and question I. Okay, the behavior of the graph, or of any graph, we have 3 types of behavior. Well, 4. We have increasing, decreasing, constant, and undefined. The 3 that we are going to talk right now, it is going to be, well, we are going to go over those 4 behaviors. All right? So the first thing that I'm going to discuss, when we read the graph from left to right. When we read the graph from left to right and we see that the graph goes down, that is a decreasing behavior. That it is a decreasing behavior. Okay. When we are going to talk about the decreasing behavior, we need to take into consideration the boundaries or increasing or any kind of behavior, we need to take into consideration the boundaries. And the question is, do we include the boundaries? For example, if go to question H. Question A says, list the intervals on which list the intervals on which f is decreasing. That's the last question. Question I. List the intervals on which f is decreasing. The first fragment of the graph that it is decreasing is from -6 to -4. When we are going to talk about location of the graph, we refer exclusively to the x values. Okay, so you want to answer here based on the x values, not on the y values, because we are talking about location. When we're talking about location, you go and refer directly to the x values. When we are talking about the value of the function, we use the y values. But when we're talking about location of the graph, we go and use the x values. Okay, does that make sense? Okay, let me help you. Let me put here the question. Okay. These are the two questions that I want to go over. Okay. List the intervals on which it's decreasing or increasing. All right. I just said whenever we are identifying location, we go by the x value. And whenever we are looking for the value of the function, we go by y values. Now, we are going to list the interval where it is decreasing. If we read from left to right, if we see that our graph goes down, that is a decreasing behavior. Okay, so right now I have seen that from -6, that is the x value, from -6 to -4, I have a decreasing behavior. So I'm going to start with that here. Okay, now my question is, am I going to use parentheses or square brackets? What do you think is the behavior on these two boundaries for this fragment? Can you determine the behavior at x equals 4? Exactly at x equals 4. At that point, can you tell me if that behavior is decreasing or increasing? Okay, x equals -4. Okay, this is the same graph. This is what you have on the workshop today. Okay. This point here, it is a turning point. So it's neither decreasing or increasing. Okay, so now when we are going to answer here, we are going to use parentheses. Also, we are going to use parentheses for -6. Why? Because there is no information whatsoever on the left side of that point. So because we determine decreasing based on that, if we read from left to right, the graph goes down, that is a decreasing behavior. Then to know if this point it is increasing or decreasing, we need to have something on the left side of that point. Since there is nothing, we cannot determine the behavior of that point, hence we use parentheses. All right? All right. So what is the other part? What is the other fragment here? That it is a decrease of the graph with a decreasing behavior. We are not done yet here because we have another fragment, Amanda, from 3, the last part, from 3 to 6, okay? 3 and 6. Okay. For increasing, you read from left to right, and if the graph goes up, it is increasing, okay? And it's basically the same. You see from this point to this point, the graph is increasing. There is just one fragment of the graph here increasing, so you need to write the interval of the x values where the graph is increasing. The other type of behavior is the constant behavior, and it is here. How would you write, or how would you identify the location of this constant behavior of the graph? From 0 to 3, here we have constant behavior. From -6 to -4, we have decreasing. From -4 to 0, we have increasing. And again, from the -3 to 6, we have a decreasing behavior. Okay, I think we did it. We have completed our first class meeting. Okay, now we are going to talk about questions. If you have questions, the recording of the class will end now. So thank you for all who are watching this on all the time. Clicking stop.